decant a portion of this infusion in an organic material into a long flask like this one. And I let the air, which is very important, come inside the contact with the liquid. If I boiled it and allow it to cool, then in a few days it will contain fully developed molds or infusoria. By boiling the infusion, I destroyed any germ there might have been in the liquid or on the walls of the flask. But as this infusion remains in contact with the air through this little opening here, it undergoes alteration like all such infusion. For instance, here, well, you see the difference between the altered and the unaltered, just the only difference between being a numbers of day. But now, suppose I repeat the experiment, but before boiling the liquids, I place the neck of a flask over a glazier torch, allowing to bend it and stretch while remaining open here. This is open. It's very important you understand that this is kept exactly as open as in the other one. Again, I then boil the liquid and allow it to cool. Now, the liquid in this second flask will remain completely unaltered. Not just for 2 days or 4 days, but months, years, 4 years. For the experiment just described has already been underway that long. And actually here, this is one experiment having gone through a century and a half long at the Institut Pasteur Museum. This was a little parenthesis in the talk. The liquid remains completely pure, as clear as distilled water. What then is the difference between these two flasks? They both contain the same liquid. They both contain air, and they are both open. Why does one undergo alteration while the other remains unchanged? Gentlemen, the only difference is this. In the case of the first flask, the germs contained in the air-borne dust can fall down the neck of the flask, reaching the liquid, where they find then appropriate nourishment, and they proceed to develop. In the case of a second flask, however, it's impossible, or at least very difficult, for air-borne to come through the neck and reach the water. Where does it go instead? It falls here on the curved neck of a flask. So when air enters the flask in accordance with the laws of diffusion, or as a result of minor change in temperature, it enters slowly, slowly enough that all of the dust and the other particles it carries fall before reaching the opening here, or along the early portion of the swan neck. Gentlemen, this experiment is generous in its lessons. For notice that everything in the air, with the only exception of dust, may enter the flask with great ease, thus coming into the contact with the liquid. Whatever you imagine air to contain electricity, magnetism, ozone, and perhaps even substances we don't know yet, it all passes through reaching the infusion. The one thing that cannot enter it is the dust, as demonstrated by the fact that if I shake violently the flask several times, in 2 or 3 days later, it will be exactly as opaque and full of animalcule as this one. Why? Because the rapid entry of air brought the infusion into contact with dust. Well, gentlemen, now I too claim showing you this liquid, like Monsieur Michelet, that I'd taken my drop of water out of the vastness of creation and taken one replete with fertile jelly. Or, to use the language of science, I could say that my droplet contains an abundance of those elements conducive to the development of the lower creatures. Oh, how I wait, how I observe, questioning, demanding this drop to go about recapitulating the process of earliest creation. For what a spectacle that could be. But alas, the droplet remains mute. Mute as it has been all these years since my experiment began. It remained thus because I've deprived it and continue to deprive it of the one thing that is not given to man to produce. I've deprived it of airborne germs or life itself. For life is the germ, and the germ is life. The doctrine of spontaneous generation will never recover from the mortal blow inflicted by this experiment.